Hi class, for section 10.3 we'll be looking at polar coordinates. So we're used to using the rectangular coordinate system, which a point is identified as x comma y. But in the polar coordinate system, the points are going to be identified as r comma theta. And we'll show you how to plot those points and how to convert from one coordinate system to the other, and how to convert from a Cartesian equation to a polar equation, and so on. So the polar grid is going to consist of a series of concentric circles. Concentric just means that you have circles that share the same center. So circles radiating out from a central point called the pole, which is the same thing as the origin. So the pole is what the origin is in Cartesian. What the origin is in Cartesian coordinates is what the pole is in polar coordinate system. All right, the positive x-axis in the polar system is called the polar axis, so it's equivalent to the x-axis. So the first coordinate r represents the length from the pole, and the second coordinate theta represents the angle from the polar axis. So let's show you how this works. So we're going to plot a point, r comma theta. So you want to move counterclockwise. Just think of the unit circle. When you go through an angle in a positive direction, you're going to move counterclockwise, just like we do in the unit circle, from the polar axis, which is the x-axis, by an angle of theta, and then you're gonna go in that direction, length r, whatever r is. Okay. And if r is negative, so here's a note for us to be careful about. If you have a negative r, then that just means that you're going to extend the point out into the opposite direction of the angle. Okay, so let's look at an example. So here's a point, 2 comma pi over 4. As you can see, first thing you do is you go to the angle pi fourths, which you start here at the polar axis, and then you're going to go out to pi over 4, and then you're going to go out 2 units. So 1, 2 units, and there it is. Let's plot one more point. Let's say we had the point, let's just say we had the point 2/3 pi is our theta, and let's say we had -3 as our r comma theta. Then first thing you would do is you want to go to 2/3 pi, which would be approximately about 120 degrees, right? So let's just say it's here. So I would recommend that you draw a full line at the angle, complete from the entire along through that angle, and instead of going positive 3 units out in the direction of 2/3 pi, you have to go in the opposite direction because r is negative. So you would go -3 units. So the point would actually be down here in quadrant 4. So your final point would be out here because of the negative r, which means move in the opposite direction. So 1, 2, 3 units there. Okay, let's look at the next page, and there will be some more examples for us to work on. Okay, so this time we are going to go to the angle pi over 2, which is 90 degrees, and we're going to go +3, which means in the same direction. So, or in the direction of the positive angle. 1, 2, 3, there it is. That is our final point. Let's say this had been a -3. If this were a -3, then instead of going in the pi over 2 direction, you would go in the opposite direction, so your point would have been down here. Okay, let's look at another example. This time we do have a -r. So first thing we do, remember, is we go to pi over 6, which is 30 degrees. So let's draw that line. This time we don't have to extend it in the opposite quadrant because r, oh, actually we do, because r is negative. So that I do recommend that you extend the line fully. This is our pi over 6. And instead of going in the positive 2 direction, you're going to go in the opposite direction, which would be out here. So that is our final point right there. Okay, let's continue down. Okay, so like I mentioned, we're going to be asked to convert from polar coordinates to rectangular, and vice versa. We're going to be asked to go from the other direction from rectangular to polar. Okay, so when you're going from polar to rectangular, you're going to use these two equations to convert. So you'll see where these two equations come from. Cosine theta is equal to x over r, and sine theta is equal to y over r. I'll actually show you now. So let's go to the next. Okay, so that's where these two equations come from, but we want to solve for x. So to solve for x, you would have to multiply both sides of the equation by r for both equations times r to isolate the x and the y, respectively. So in this case, we're going to have x equals r cosine theta. And in the other one, we are going to have r times sine theta. So these are definitely two formulas that you want to memorize. X is equal to r cosine theta, and y is equal to r sine theta. So definitely want to have those memorized. Okay, let's move on to the next page. Page really quickly. Go down to the bottom, and you'll see this triangle. See this right triangle? You have the point, the point in both forms, rectangular and polar. And you see this, you can draw this right triangle. You can label this x, y, and this is r. And so if you do the cosine of theta, you'd get x over r. And if you do the sine of theta, you get y over r. And that's where those two equations come from. Okay, let's go back to where we were. Previous page. Okay, so now they're going to ask us to convert from polar to rectangular. So just like I mentioned, this is your r comma theta, and we would like to represent that in rectangular form, which is x comma y. So to get x, you need this formula, x equals r cos theta. And to get y, you would need this formula, y equals r sine theta. So let's plug in the values. R is 3, theta is pi over 2. And let's just do both of these at the same time. If you look at your unit circle, the cosine of pi over 2 is 0. So therefore, this coordinate is 0. That's your x coordinate. And your y coordinate is going to be 3 sine pi over 2 is 1. So that's going to be 3. All right, so our final answer should be written in the form of a coordinate or ordered pair. So you want to write your answer in this form, x, comma, y. And that will do it. So that's the final answer in rectangular coordinates. The other thing you just want to check is to make sure you're in the same quadrant. You should be in the same quadrant, right? Well, or in the same location. If you were to graph this point, it would be, if you were to graph that point, you would go to pi over 2, which is up here, 90 degrees, and you would go 3 units out, 1, 2, 3. Of course, these would be circles, concentric circles. Sorry, that should be a 3, not a 2. So that would be, right here. And as you can see, if this were a Cartesian coordinate or a rectangular coordinate system, 0, 3 would be in the same exact position as this point. So these 2 points should basically be in the same exact spot. Okay, let's try another one. This one, same thing. So let's go ahead and use those two formulas again. X equals r cos theta. Y equals r sine theta. This is going to be -1 cos 2/3 pi. This is going to be -1 sine 2/3 pi. Okay, so we get over here, the cosine of 2/3 pi is a -1/2. So this is going to be +1/2. And the sine of 2/3 pi is radical 3 over 2. So this should be -radical 3 over 2. So now we have both coordinates, x and y. And now we can write it as a ordered pair. So let's write our final answer as an ordered pair. So it's going to be 1/2, comma, -radical 3 over 2. And remember to double check that the 2 points are in the same quadrant. So let's check that really quick. So if you go to 2/3 pi, that's going to be over here, 120 degrees. And instead of going in the positive direction, or in the direction of 2/3 pi, you're going to go in the opposite because it's a negative r. So your point would be somewhere out here in the fourth quadrant. And that's exactly where you want it to be because positive, negative is quadrant 4. So it's actually a good idea to just kind of start off the problem by listing out what quadrant your point is in. That way you can see your final rectangular coordinate, make sure it's in the same quadrant. Okay, let's move along. Let's move down here. Okay, so now we got, now we're going to go in the opposite direction. We're going to go from rectangular coordinates to polar coordinates. So when you go in that direction, you do want to use a different set of formulas. So here are the formulas that you would want to use to go in that direction. So if you apply the Pythagorean theorem here to this triangle, x squared plus y squared equals r squared, that's the first formula that we want to use. Or that's one formula to use. The other formula is given by tangent of theta. So the tangent of theta is opposite over adjacent. So here's our opposite, and here's our adjacent relative to this angle. So the ratio is going to be y over x. So these are the other two formulas that you really want to have memorized. X squared plus y squared equals r squared, and tangent of theta is equal to y over x. So there's a total of 4 formulas in this section that you really want to memorize. X equals r cos theta, y equals r sine theta, and now you have r squared equals x squared plus y squared, and tangent theta is equal to y over x. Okay, let's look at the next page. Okay, so like I mentioned, now we are going to go in the direction of converting from rectangular to polar. So that means that this point is your x, and this coordinate is your y coordinate. So first we've got to find the r by applying this formula, and then we'll find the theta by using this formula, and then we're good to go. Okay, first things first, let's identify the quadrant. Well, 3, 3 is in quadrant 1. All right, so our final point should also be in quadrant 1. Okay, so let's plug in x, which is 3 squared plus 3 squared is 9 plus 9, which is 18. Don't forget to take the square root, which gives us plus minus. And you can also break this up. That's 9 times 2. The square root of 9 is 3 rad 2, plus minus. All right, so what I did here is I called this 9 times 2. The 9 comes out of the square root as a 3, and so now you have 3 square root of 2. I'm just simplifying the radical because there's a perfect square factor in 18. Okay, so we have plus minus 3 square root 2. Now let's find out what tangent theta is equal to. Tangent of theta is equal to 3 over 3, all right, which is 1. If you look at your unit circle, in quadrant 1, what angle has a tangent value of 1? Well, remember, tangent is y over x, and the angle in quadrant 1 that has a tangent of 1 is pi over 4. So that would be theta is pi over 4. Okay, so therefore we can represent this point as r. If you go with the positive r first, then you want to be in quadrant 1, so you want to go pi over 4. But let's say we wanted to use a negative r instead. So here's our pi over 4. And if you recall, this angle down here is 5/4 pi. Okay, if you look at your unit circle, you'll see that this is 5/4 pi down here, and this is 1/4 pi over here. So if you want to go with the negative r, so there's 2 ways you can write your final answer. You can also write it as negative 3 rad 2, but since we need to be in quadrant 1, that means instead of going, if you're using the negative one, you would have to go in this direction so that you can go in the opposite direction, which is quadrant 1. So the angle is what I'm getting at is 5/4 pi. But because of the negative, that's going to go take us in the opposite direction, which is quadrant 1. So there are two ways to represent your final answer. You can either represent it as a positive r, using the angle pi over 4, or as a negative r, but then you would have to use the angle that's opposite pi over 4, which is 5/4 pi. So either answer is correct. It's completely up to you which one you would rather use. I would probably rather go with the positive r. Okay, let's continue. Okay, now we're going to transform equations. We're going to use some substitution. So they're going to give you an equation in a certain either Cartesian, and then they'll have you convert it into a polar equation, or vice versa. They'll give you an equation in polar form and ask you to convert it into a Cartesian equation. So here are some strategies. You would want to convert from rectangular to polar, you are going to want to most likely use these two formulas, the formulas that we already looked at and we have memorized. And then in the opposite direction, if you're going in the opposite direction from polar to rectangular, you're going to want to replace r squared with x squared plus y squared. You want to replace x with r cosine theta. And you want to replace y. I don't know why they didn't write it here. You want to replace x. Whoops. That's not what I wanted. You want to replace x with r cos theta, and you want to replace y with r sine theta. Okay, so let's look at this first example. So as you can see, we do have a Cartesian equation. Cartesian means rectangular coordinates. As you can see, x's and y's. And you want to remove those x's and y's and instead have r's and thetas. And that would make it, that would write it in polar form. Okay, so right away, hopefully you guys see x squared plus y squared can be replaced with r squared. That's one of those that we have memorized. So let's start there. Whoops. R squared equals 6y. So all I did was I replaced x squared plus y squared with r squared. Okay, so that became that. The next thing I can do is I can replace y with r sine theta. And that's our next step. R squared equals 6r sine theta. However, we're not done. Even though we have the equation in r's in polar form, we do, r's and thetas. The next thing they want us to do is, though, they want us to solve for r. So we have to solve for r. So to solve for r, you want to set this equation equal to 0 and then factor out the r. So let's go there. So subtract 6r sine theta so that the equation will be equal to 0. Okay, so we have r squared minus 6r sine theta equals 0. Now we can factor out the r. Okay, so once you factor out the r, then you're going to set each factor equal to 0, just like we do when we solve an algebraic quadratic equation. You set the individual factors equal to 0. Okay, so that's going to be r equals 0, comma, r minus 6 sine theta equals 0. However, if you were to look at the graph of this is just a point, a single point at the pole. This is basically the origin. So you can use Desmos.com to verify this equation here, r equal to 0. It's just the pole or the origin. So that's not really the answer because that's not equivalent to the graph of this Cartesian equation, which if you were to graph it, you would see is actually either a circle or some form of conic sections. It could be an ellipse or a circle or hyperbola, but clearly this is not the right answer. So it's going to be this one. You will see. All right. So solve for r, and that's our final answer. R equals 6 sine theta. Okay. So we are done here. So if you were to graph both these equations on Desmos, you can graph this in a polar coordinate system on Desmos.com. Look at the graph and then graph this one in Desmos.com using the rectangular coordinate system, and you will see they're the exact same graph. Okay, let's try another one. Let's go to the next page. Okay, same idea, but this time we're going from polar to rectangular. Sometimes they use a word Cartesian. That's interchangeable with rectangular. It means the same exact thing. They just called the rectangular coordinate system after René Descartes, a famous mathematician, French mathematician. Okay, so let's see what we could do. This time we want to replace the r's and thetas with x's and y's. So let's use the definition of secant to rewrite this equation as r equals 2 times 1 over cos theta. Okay, we can multiply both sides of the equation by cos, and the reason I want to do that, you will see in just a second, is because now I have r cos theta equal to 2. And this should look very familiar, r cosine theta. Hopefully you guys recall that r x is equal to r cos theta. That's one of the formulas that we have memorized. So that's why it's important to have these memorized, because then you can automatically see that that is going to become x equals 2. Okay, and that's our final answer. All right, once again, if you want to double check your answer, go to Desmos, type this into the Desmos and graph that. You'll see it's just a vertical line. And then if you graph this, you will see it's also going to be the same exact graph. Okay. All right, let's continue down to the next problem. It's actually the last problem. So same thing, we have another polar equation that we want to write in Cartesian form. So it looks like the thing that we can do here is to multiply the equation by the denominator. Let's multiply both sides of the equation by the denominator. So we have r equals 3, 1 minus 2 cos theta. Multiply both sides of the equation by the denominator like we usually do. Okay, these are going to cancel out. All right, and we are going to have to distribute the r. So once you distribute the r, you should get r minus 2r cos theta equals 3. All right, and hopefully you guys see the opportunity to substitute out r cos theta once again. You should know that that is an x. That becomes x, so now we have r minus 2x equals 3. So we're getting closer. So at this point, we don't really have an equation for r. We have an equation for r squared, but there's no square here, so we can't use the r squared equals x squared plus y squared formula unless we get creative. And by that, I mean add 2x to both sides. And so now we have r equals 2x plus 3. And since we don't have a formula for r, but we do have a formula for r squared, the next thing we can do is square both sides. So square both sides of the equation, and that, you will see, will allow us to substitute our formula that we've been wanting to use, this one, the Pythagorean theorem equation, r squared equals x squared plus y squared. So now we can use that to replace r squared with x squared plus y squared on the left side. The right side, we can expand this out since it's to the second power and expand it out. So once you've expanded that out, you should get 4x squared plus 12x plus 9. And the only thing I would say is let's just combine these. Let's get the x squares. Let's combine the x squares. So that's the only like terms that I see here. So let's subtract 4x squared to both sides so that we can combine those together. And that will do it. So our final answer should be negative 3x squared plus y squared equals 12x plus 9. And that's as far as you really need to go for these problems. As long as you replace all the r's and thetas with x's and y's, then you are good. Okay, that completes this section.